parallax error. So parallax error, due to this error are more likely with these instruments as the pointer moves over a fixed scale. So because of this parallax error, these instruments are not very much suitable for high accurate measurements. So next is comparison of comparators and measuring instruments. Comparators की ने ये भी एक measuring instruments ही ने, but there is some basic difference between the measuring instruments and comparators. Comparators are measuring instruments but not gives us the direct value, as the comparators do not measure the actual dimension but indicate only the difference from standard value. So जो comparators ने वो सानू direct value या direct dimension नहीं दे रहे, वो simply सानू की कह दे रहे ने, सानू वो डायरैक्ट डिफरेंस जो है, डिफरेंस जोड़ा है स्टैंडर्ड वैल्यू ते इंडिकेटेड वैल्यू का या ट्रू वैल्यू का एक्चुअल डिमेंशन का दे रहे हैं. सो इन मेजरिंग इंस्ट्रूमेंट दी मेजरिंग they measure the actual value of the dimension. So measuring instrument ਨਾਲ ਅਸੀਂ direct value ਸਾਨੂੰ ਮਿਲ ਰਹੀ ਹੈ, output ਮਿਲ ਰਹੀ ਹੈ ਕੀ dimension ਹੈ, but comparator gives us only the difference between actual dimension as well as the standard dimension. So this is the basic difference between comparator and measuring instrument. So second one is the readings are magnified. So in comparator, because there would be a very small deflection, small variation, so magnification is must coupled with comparators, but from measuring instrument point of view the readings are not magnified. So this is also the difference between the comparator and measuring instrument. Next is comparator can check many components at one time and consume less time. So comparators ने जेडे versatile ने, they can check more than one dimension at a time, but measuring instruments take more time as only one component is measured at a time. So this is also a plus point of comparator, that they can check many components at one time and consume less time. So more suitable for mass production, as they can check more components at a time, so more suitable for large scale production, that is mass production. And measuring instruments, as they only can check one component at a time, they are not suitable for mass production or large scale production. Comparators can check dimensions as well as geometrical forms. So ਕੰਪੈਰੇਟਰਸ ਦੀ ਕੀ ਵਰਸੈਟਿਲਿਟੀ ਹੈ, ਉਹ ਡਿਮੈਂਸ਼ਨਸ ਤਾਂ ਚੈੱਕ ਕਰ ਹੀ ਸਕਦੇ ਨੇ, ਡਿਮੈਂਸ਼ਨਸ ਤਾਂ ਲੈ ਹੀ ਰਹੇ ਨੇ, ਪਲੱਸ ਨਾਲ ਉਹ ਜਿਓਮੈਟਰੀਕਲ ਫਾਰਮਸ, ਟੇਪਰ ਹੈ, ਓਵਲਟੀ ਹੈ, ਸਰਫੇਸ ਫਿਨਿਸ਼ ਹੈ, ਸਰਫੇਸ ਰਫਨੈਸ ਹੈ. ਸੋ ਦਿਸ ਟਾਈਪ ਆਫ ਜੋ ਕਰੈਕਟਰਿਸਟਿਕਸ ਨੇ, ਜਿਓਮੈਟਰੀਕਲ ਫਾਰਮਸ ਨੇ, ਉਹ ਵੀ ਉਹ ਚੈੱਕ ਕਰ ਸਕਦੇ ਨੇ ਵਿਦ dimensions also, but measuring instrument cannot be used to check the geometrical forms. So geometrical forms ਅਸੀਂ measuring instrument ਨਾਲ ਨਹੀਂ ਚੈੱਕ ਕਰ ਸਕਦੇ, ਉਹ geometrical form ਚੈੱਕ ਕਰਨ ਲਈ particular ਹੀ measuring instrument ਹੋਏਗਾ, but comparator can compare the dimensions as well as check the geometrical forms also. ਇਹ ਵੀ plus point ਹੈ, versatility ਹੈ comparators ਦੀ. So this is all about the comparator. Or next is clinometer. The next topic of today's lecture is clinometer. So what is clinometers? A clinometer is a spirit level mounted on a rotary member. The angle of inclination of the rotary member relative to its base can be measured by the circular scale. There are various types of clinometer. So one is vernier clinometer. It consists of a spirit level mounted on a rotary member carried in a housing. One face of the housing forms the base of the instrument. There is a circular scale on the housing. So this is the vernier type of clinometer. This is spirit level and this is the rotary member. Rotary member can rotate around this hinge, and this is the circular scale, and this is the housing of the clinometer. So this spirit level is mounted on the rotary member carried in this housing. One face of housing forms the base of the instrument. So housing's one face form the base, and there is a circular scale also in the housing. So basically clinometers are used to measuring angles. So angular measurements ਵਾਸਤੇ ਅਸੀਂ ਇੱਕ instrument ਆ ਸਾਡੇ ਕੋਲ which is called clinometer. The angle of clinometer of rotary member relative to the base can be measured by a circular scale. So a circular scale we can check the angle. The scale may cover the whole circle or only the part of the circle. The scale, it may cover the whole circle or the part of it. Clinometers are generally used to determine the angle included between the two adjacent faces. So the base of the instrument is placed, so this is the base of the instrument that is placed on one of the surface of the rotary member, is adjusted till zero reading of the bubble is obtained. So the angle of the rotation is then noted on the circular scale against the n index. The instrument is then placed on the other surface in this way, and the reading is taken in the similar manner if theta and phi are the readings of the instrument. So if this is the theta reading when this scale points with the zero reading, and here the reading of angle is phi when it rotary member is adjusted to the till zero reading of the bubble, then then the angle included angle between the surface should be alpha is equals to 180 minus theta minus phi. So जो angle जो है जो ਅਸੀਂ find out करना, this is the alpha angle which has to be find out. So this angle should be 180 degree. This total angle is 180 degree. So we can to find out this alpha angle. So alpha is equal to 180 degree minus theta minus phi, or we can say this theta angle is given by this clinometer left side, and the phi angle is given by right side of clinometer. The other clinometer is micrometer clinometer. In this type, spirit level is attached at one end of the barrel of a micrometer. So here spirit level is attached at the one end of the barrel of micrometer. So this is the barrel of micrometer. The other end of the spirit level is hinged. So other is hinged on the base. The base is placed on the surface. So this is the base. Base is placed on the surface whose inclination is to be measured. The micrometer is adjusted till the level is horizontal. So this adjustment is made by this micrometer. So this type of clinometer is used for measuring small angles. So with the help of micrometer we can measure small angles, and this is all called micrometer clinometer. So what are the uses of clinometers? Clinometers are used for checking included angles, relief angles, small type of angles, as well as angular faces on large cutting tools and milling cutter inserts. They can also be used for setting inclinable tables on jig boring machines and angular work on grinding machines, etc. So these are some uses of clinometers. So the next topics is precision and accuracy. So basic difference between precision and accuracy. Let we see first precision. The repeatability of the measuring process is known as precision. Precision indicates to what extent the measurements agree with each other. If the measurement of same characteristic is performed under identical conditions, it refers to a group of measurement rather than a single measurement. So accuracy की है एक single reading है as comparison to true value जो output आई है, but the precision is a group of measurements. A precision instrument is concerned with the precise determination of the linear, angular and non-linear functions to maintain the closed dimensional tolerances, the components should be checked precisely. So a precision instrument will indicate same reading for same dimension when measured again and again. A non-precise instrument will indicate widely varying readings. So what about accuracy? So accuracy is the degree to which the measured value is close to the true value. So ਅਸੀਂ instrument ਉਨਾ ਹੀ ਸਾਡਾ accurate ਹੋਏਗਾ ਜਿੰਨਾ ਸਾਨੂੰ ਉਹ ਜੋ actual value ਹੋਏਗਾ true value ਜਿਹੜੀ ਹੋਏਗੀ ਉਹਦੇ measured value ਦੇ close ਹੋਏਗੀ. So it refers to the closeness to the true value. The difference between the true value and measured value is called error of measurement, and the instrument showing lesser error is more accurate. Every part has some true dimensions, and the purpose of measurement is to ascertain those true dimensions. But no measurement can be absolutely correct, and there is always some error due to numerous reasons, the number of reasons some errors are there. Thus the true dimension can never actually be determined, it can only be approximated. These instruments of accuracy plus minus 0.01 mm indicates that the dimension of a part of 50 mm could lie between 49.99 and 50.01 mm. This accuracy means that the measurement can be inaccurate by plus minus 0.01 mm, or there is uncertainty about the true value to the extent of plus minus 0.01. So students, today I have covered the topics which is basically related to comparators. So introduction, first of all comparators, then need of comparators. What is the need of comparators? Basic principle of operation. Basically we have seen today mechanical type of comparators, that is dial indicator, then various uses of comparators, and one important part is what are the essential characteristics of comparators, and then classification of comparators, what are different types as electrical, electronic, optical, pneumatic, mechanical, etc. Then mechanical type of comparators, what are the various advantages and disadvantages of mechanical type of comparator, and finally comparators versus measuring instruments. Basically comparators are also measuring instruments, also a part of metrology, but still there is some difference, basic difference between comparators and measuring instruments. That's all for today. Thank you.